Okay, so let's go a bit more deeply into the mathematics. So if you focus here on the left, we're going to look at what is called the LR shuffle. That's shuffling into a left and right pile, in which we will stack the left pile on top of the right. And it leads to this permutation. Okay, so we're going to talk about permutations and notation for permutations. Okay, and I promise you this is not that difficult. Anyone can follow this, regardless of your mathematical background. Okay, so to figure out what permutation is associated with this shuffle, what we do is we begin with cards clearly labeled 1 through 8. These numerals are really just marking the original position of these cards. That's the whole reason for the numerals. Okay, so that's where we're starting. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now what you do to find the permutation associated with that shuffle is you turn the cards over and you perform the shuffle. So we're going to do a left-right with stacking left pile on top of the right. Very good. That is the shuffle. What is the new ordering brought about because of that shuffle? Well, let's take a look. Okay, let me just put this down so you can see it. So it's 7, 5, 3, 1, 8, 6, 4, 2. Okay, so what I've done here is I've simply written down the new ordering. 7, 5, 3, 1, 8, 6, 4, 2. And this is called Cauchy's two-line notation. It's a way of representing permutations. It's a way of representing the result of this shuffle on this packet of 8 cards. Now, this isn't what we have up here. We have something far more compact. So what we do is we change this two-line notation into something called cycle notation, or in other words, one-line notation. So this is far more compressed and succinct. Okay, so the way that you get the one-line notation, so the way that I got the 174 up here, so you just read it off here. So we see that 1, so what was in position 1 gets replaced by what was in position 7, right? So 1 goes to 7. So we say 1 goes to 7. Where does 7 go? 7 over here, we're looking at the top row. 7 goes to 4. Very good. Where does 4 go? Well, 4 goes to 1. Well, guess what? That wraps around. We started at 1. We went from 1 to 7, 7 to 4, 4 to 1. So that creates a little cycle of 3 elements. Okay? So a way to compress all of that information into as few characters as possible is the following. We start with an open left parenthesis, and then we just write the value 1, 7, 4, and then close with a right parenthesis. Where the assumption here is the 4 wraps around to the first value in that cycle, namely 1. So the information here is capturing what's happening with 3 of the elements in our original sequence. Okay, now let's take a look at some more here. So 2 goes to 5, so there's an arrow there. Where does 5 go? 5 goes to 8, so I've written an 8 to the right. Where does 8 go? 8 goes to 2, and 2 is where we started, so it wraps around. So all of this information here can be consolidated into just these symbols here. Parenthesis, 2, 5, 8, close parenthesis. Okay? Now what is happening with the others? So look at 3. Ooh, that's interesting, and you can see it. So remember, this is the top card. So this is position 1, 2, 3. Oh, the card in position 3 stayed in position 3. So that's why we have an arrow from 3 to 3. And we write it as a single cycle. It's called a fixed point. So if you perform this shuffle 1 time or 1,000,000 times, 3 stays right where it started. It doesn't go anywhere. It's a fixed point. The same thing happens with whatever was originally in position 6. This is position 6. It didn't go anywhere. It stayed right where it is. Despite all the movement of those cards, as we're shuffling it, the cards in position 3 and 6 just arrived back where they started. They did not get moved to a new position in the end. Now, ordinarily, these one cycles, we call them, are not necessarily included in the cycle representation of the permutation, provided that the context is clear regarding the size of the set you're working with. So as long as we're clear on the fact that we're looking at 8 objects, we can safely drop these. And because a 3 is not present, it's assumed to be a fixed point, which it is. And because a 6 is not present anywhere in these parentheses, it's assumed to be a fixed point, which it is.